Hey guys, today we're looking at target 1C, which is I can make decisions about the results of the sum and product of rational and irrational numbers. And our MLO is that we can identify rational and irrational numbers by comparing the definitions. So we have to know what a rational and an irrational number is. A rational number, if you look at the actual word, the first part says ratio. Okay, so a rational number is a ratio, and a ratio is just a fraction when you compare two different numbers to each other, like boys to girls in the class. That would be a ratio. So I'm going to give it a definition. I'm going to zoom in here to write a little bit better. But the definition of rational number, numbers that can be written as a fraction A over B, where A and B are integers. So some example of rational numbers. An integer is a rational number. So an integer would just be, for example, negative 125. So just your normal numbers you probably think about. Or 6, or 273. Okay, those are integers. And those can actually be written as a fraction because you could write negative 125 over 1. That's a fraction, and negative 125 over 1 is just negative 125. Other examples of rational numbers are fractions. Any number that can be written as a fraction. So 2/5, which is 0.4. Yeah, right, or in between. So 2/5 or 0.4, that means the same thing. Another example is 1/8, or that's the same thing as 0.125. Okay, so 1/8 and 0.125 and 2/5 and 0.4 and 6, those are all rational numbers. All right, irrational number is not written as a fraction. You cannot write these numbers as a fraction. So I'm going to zoom in here and write the definition. My handwriting is a little better. Numbers that cannot be written as a fraction. So for example, anything that is a radical or a square root. So square root of 7, or 2 to the 1/3 power, because 2 to the 1/3 power is just the cube root of 2. Okay, so that would be a radical. That is an irrational number. You cannot write those as fractions. Anything non-repeating or non-terminating decimals. So let me write that down. Non-repeating or non-terminating. That means it just does not end. non-terminating decimals. And an example of probably the most common example of an irrational number is pi. You know, pi, when we use the area of a circle or circumference of a circle, you know, pi 3.14159, it keeps repeating on and on forever. So since it never ends and there's no way to write it as a fraction or a root, we use that symbol pi. So let's look at some examples. We want to determine whether the number is rational or irrational, and we need to explain. Example 1, square root of 47. So when I see square roots, I always want to try to simplify them, meaning I look for perfect squares. So for example, if I have square root of 9, that was the same thing as 3. But square root of 47 cannot be simplified anymore. That is simplified all the way in rational form. So since it is in rational form, right, it is a radical, just like we see up here. Square root of 7, it's all the way simplified. Square root of 47 is the same idea. So on here we would write if it's irrational, irrational. And the reason is because it is a radical. Okay, like the square root sign, the cube root sign, stuff like that, that is a radical and cannot be simplified to anything less than that. Example 2, 11 over 9. Well, it's a fraction. Okay, anything you can write as a fraction is rational. And the reason is it is a fraction. Example 3, 96 to the 1/2 power. Okay, remember 96 to the 1/2 power is the square root of 96. And since that is a radical, it will be irrational. Irrational, and the reason is because it's a radical. It cannot be written as a fraction. Square root of 36. Okay, square root of 36 looks like this example here, right? Square root of 47, and it's a radical. But this one can be simplified, so we need to be careful. Square root of 36 is just 6, and 6 is an integer. So that would make it a rational number. Rational. Whoops, handwriting's not good on this today. And the reason is it is an integer. Okay, an integer can be written as a fraction. 6 over 1 or just 6. Last two examples. -8. Again, that is just an integer, so same as example 4, it's a rational number. Rational. Because it is an integer. And then lastly, example 6, 3 times the square root of 7. So that's, 3 is an integer, but because that's the square root of 7 on there, we plug that in our calculator, 3 times square root of 7, you're going to get this long decimal that never ends. And that square root of 7 is a radical, so that this makes an irrational number. It cannot be written as a fraction. Irrational. And the reason, it is a radical. Okay, that square root of 7 there makes it radical, just like the square root of 47 there cannot be simplified even more. Whereas this one it could, so it's just an integer.